Let's take a look at a question here from Naval Base Secondary. The mass m milligrams of a radioactive substance present T years after first being observed is given by m equals to 300 multiplied by 0.4 plus e to the power of kt. The initial amount of the substance is 420 milligrams. It takes 3 years for the mass to decay by 250 mg. Thus, k equals to negative 0.597. Sketch a graph of m against t. Now let's take a look at this one here. We need to sketch a graph for m versus t. Let me just put a graph over here first. And because I know m is mass, it's going to be positive. And t is time, it's going to be positive as well. So I'm going to draw my axis this way. Alright, now let's take a look at the features of exponential graph. For exponential graph, you have key features. Number 1, I'm going to find out what the asymptote is. So the asymptote of the graph for this question here, we will need to expand the 300 inside. Let me rewrite this again. It will be 120 plus 300 e raised to the power 0.597t. Alright, now this standalone number here will be the horizontal line, so I just label. So for this horizontal line, this label is m, so it cuts m at 120. So this asymptote for this graph will be m equals 120. Right, so we're done with first key features of the graph. Let's look at key features. Number 2, the vertical intercept. I'm just going to call it capital Y-intercept for this case. This is actually m. So what happened here is that we are given the initial amount. So that's going to be where you start. So this Y-intercept here, I will have m equals to 420 because I'm given by the question. Alright, now let's look at key features number 3. Now this one here for exponential graph, sometimes you have it, sometimes you don't. Now let's take a look at this one here. Now, capital X-intercept, which means this one here. So if you want to find the intercept over here, we're going to equate the opposite, which is m equals to 0. So let's find out whether we will have capital X-intercept. So take the equation over here. Let me just equate. 0 equals to 120 plus 300 e raised to the power negative 0.597t. Let me move 120 to the left. Now you notice that here we have a negative number. Even if I move 300 to the left, I'll have exponent raised to the power negative 0.597t equals to a negative number. And the next step, I'm going to take ln, so I'm not allowed to take ln of a negative number. So for this one here, there will be no solution. Okay, so since I have no solution, means I do not have a horizontal intercept for this question here, which is okay. Now let's take a look at these two here. Key features 1 and 2. I'm going to place it in here. So I start at 420. So I have a point here. 420. Asymptote at 120. Let's draw dotted line. 120. Now you also notice there's a keyword that I have highlighted in red. That's this word decay. So if you understand the word of decay, means it has reduces over the time. So for this one here, we're going to sketch a graph approaching asymptote this way here. Alright, so that's all for this exponential graph question here.